All right, today we're going to talk about catalysts. Catalysts, as we remember from the very beginning of this unit, are things that make a reaction go faster. And the way that they make a reaction go faster, we've already seen it in reaction mechanisms, is it shows up as a reactant and then shows up as a product again, so it doesn't appear in the overall equation. Okay, now, for example, let's say we have a reaction where you have A making B, okay? And that's just a one step, that is the overall reaction, but it's also the reaction mechanism as well. You know, it's a rearrangement reaction. Okay, let's say we have another reaction, though, where A reacts with D to make C, and then C will react and turn into D and B. So here's step one, here's step two. In this case, you can see that C is an intermediate, so it's going to cancel out. D is in this case, because you start with an end with it, it's also, in this case, a catalyst. Okay? So remember that if you start with something and end with something, that is a catalyst. And what this does, what a catalyst does, so again, here's the first reaction, and it's the same reaction, but now this one has a catalyst in it. And what it does is it basically makes it so that the reaction, that this reaction here is going to have a lower activation energy than this reaction here. So it provides an alternate or an alternative reaction mechanism with a lower activation energy. Okay, so this reaction here would be represented by the dotted line, where this reaction here would be represented by the complete line there. Okay, so a catalyst provides an alternate or a different reaction mechanism that the slow step has a lower activation energy. And so if it has a lower activation energy, then more particles have enough energy to overcome this new lower activation energy barrier, and a greater number of the collisions will be successful, which will result in a reaction. Notice that the overall energy change from here to here does not change. When you add a catalyst, it does not become more exothermic or less exothermic or endothermic. The energy change, or in this case, we're going to call it the enthalpy when we get to Unit 5, is the same whether it's the catalyzed version of the reaction or the uncatalyzed version. Okay, and again, just a couple things. Remember that in a reaction mechanism, a catalyst appears as a reactant, and then again as a product, and again in general does not appear in the overall equation. And it usually doesn't appear in the rate law. It definitely does not appear in the overall equation, but again, we've seen examples where it does appear in the rate law, again, sometimes. Okay, and again, make sure we understand this. When you change, a catalyst is the only thing that changes the activation energy. Okay, and it does that by providing that alternate reaction mechanism like we saw right here. When you change the temperature, that does not change the activation energy. An increase in the temperature simply gives more molecules enough energy to overcome the activation energy barrier. I know I've said that a whole bunch this unit, but it's really, really important, and it's really easy to mix up. That, oh, you raise the temperature, sure, the activation energy goes down. No, it does not. Okay? So here you can see what happens is that when you provide this catalyst, this is how many molecules can react before, but now with the catalyst, you've got this many molecules that can now react, because again, you've lowered that activation energy barrier. So basically, we've moved that green line from here over to here, which again means now more particles can react of the overall total number of particles. So in summary, catalysts again provide an alternative pathway with a lower activation energy. This means that more particles will possess this lower minimum energy, and as a result, a greater number of particles will be able to overcome the activation energy barrier, which means a greater number of collisions will be successful, and that makes the reaction go faster. Okay, now some different types of catalysts. You don't necessarily need to know these specifically, but just to kind of see some examples. Sometimes you have an acid or a base that act as a catalyst. Here is the acid, here is the base. Notice that you start with it and then you end with it again. So again, in the overall equation, it's going to cancel out. Same thing with the base with the hydroxide there. In both cases, they both are acting as catalysts. You're starting with those and you're ending with those. And then, let's see, you can also have what are called, so there's acid-base catalysts. You can also have what are called surface catalysts. And a surface catalyst is one where, like inside your car, you have inside the muffler of your car, you have a thing called a catalytic converter, which is basically just a piece of metal. And as the gases travel over it, that metal acts as a catalyst. And the nice thing is, again, you start with it, you end with it. That piece of metal never, ever goes away. It's not like it wears down over time because it's a catalyst. So it gets used, but then it comes back again at the end of the reaction. Okay? So a piece of metal, usually it's like a piece of palladium, I believe is what it is in your car muffler. That is a surface catalyst. Okay, and then the final one is in biological. Inside your body, you have these things called enzymes. And enzymes are catalysts that, again, they reduce the overall activation energy of the reaction by providing a site where molecules can come in and basically land and then break apart easier because of that enzyme. Okay, so you've got acid base, you've got surface, and you've got enzymes. Again, don't need to memorize that. Just know that those are some different types of catalysts. Okay, and then example 1, just is a pretty easy question here. Here you've got the proposed mechanism. A student claims that the compound Na is a catalyst. Do you agree or disagree with the student's claim? Explain your choice. Of course, we are going to disagree with that comment. And why? Because Na is formed and then used again, which is an intermediate. Okay? And that's all you would have to say on that question.